So in this section, we'll go over subnets and subnetting. And subnetting is unfortunately one of the hardest things to understand about AWS by far. However, if you're going to do anything useful in AWS, you have to become proficient with subnetting and subnets. So what is a subnet? A subnet is essentially short for subnetwork, or a small subsection of the entire VPC. So our VPC is part of AWS and our subnet is a part of the VPC. And essentially it's a way to divide up your entire VPC for performance and security reasons. So for example, you want to deploy a database in a subnet that is inaccessible by the internet, while another subnet has web servers and it will need to be accessible by the internet. So you'll have two subnets, but they're still going to be part of the same VPC. And subnetting in AWS is done with CIDR notation, which we'll see in a second, instead of classes. So let's now talk about subnet masks. Subnet masks are a way to divide up your subnet into an approximate number of IP addresses. So an example subnet CIDR notation would be 10.11.12.0/24. So your entire VPC would be 10.11.2.0 and /24 would be the subnet mask, which would divide up your VPC. So /24 basically means the first 24 bits are to be used as a network prefix and are therefore unusable. Since IPv4 has 32 total bits, we have 8 bits left, which are known as a host address, and these are the usable IP addresses for the CIDR notation. Since 8 bits has 256 combinations, our subnet therefore can be any address that is between 10.11.12.0 and 10.11.12.255, since again we start counting at 0. And 1s represent the network prefix and 0s represent the host address. So just know, if we're doing /24, that means the first 3 octets are unusable, because again they are representing the network prefix. Only the last octet, which is 0.0, can have any value at all. So this is essentially what allows us to have a subnet. It's the combination of a network prefix and a host address. And again, remember, /24 is the same exact thing as writing 255.255.255.0, and which is the same as having 1s for the first 3 octets. And as we just saw, 1s represent the network prefix. So the network prefix is not part of the IP addresses we can use. The IP addresses which we can use is represented by 0s, which is the last octet. So again, our usable IP addresses are any IP address between 0 and 255. And don't worry too much if you don't totally understand this. This will become much clearer when we set up our VPC in AWS. This is just a basic primer. So in the last slide, we saw our subnet and it was divided evenly into octets. So we had 3 sets of 1s and 1 set of 0s. But a subnet doesn't have to evenly divide into octets either. For example, you can have a subnet mask of /19. So what this will look like is 19 1s followed by the remaining 0s. And as you can see in the third octet, it does not divide evenly. We have 3 1s and 5 0s. And let's go to a subnet calculator and see how this works. So a subnet calculator basically lets you see how many IP addresses a subnet can have. So if we do 10.11.12.0/19 and we hit calculate, we see at the very bottom host/net equals 8,190 private IP addresses we have available to us. And as you can see, the host min is 10.11.0.1. And again, it doesn't count from 0. And you'll also see host max. It only goes up to 254 because the broadcast and the network address. And again, we don't have to go in too much detail about the network and broadcast addresses because they're special IP addresses you need to handle some utility functions, but just know that we have 10.11.0.0 available to us. It's just used for a special purpose. And that's same with 10.11.31.255, which would be our last IP address, but it's being used as a broadcast. So what I want to point out is our host max, which is our maximum IP address, it's 10.11.31. So just ignore 254, but 0.31. Why is it 0.31? Shouldn't we have any IP address within 2 55 and 0. Why is our host max, the maximum IP address, only 31? So to understand that, let's go back to our slide. So since the first two octets are all ones, both the octets are used for the network prefix. But our third octet has only the partial network prefix, and we only have 5 bits to use as our host address. This means the second octet can only be a number between 0 and 31, since 2 raised to 5 is 32. And our last octet is all zeros, so as normal it can be any number between 0 and 255. So altogether, this means that our subnet can be any address that is between 10.11.0.0 and 10.11.31.255. So let's continue talking about subnet masks. So we just saw /19 in the last slide, but it's better to just use increments of 8. Doing so will ensure that all the octets are either a host address or network prefix. So this means /8 will have the entire last 3 octets available as IP addresses. /16 will have the entire last 2 octets, and /24 will have the entire last octet. So this is why it's better to just have subnet mask in increments of 8. And of course, we'll see this when we set it up. And finally, here's a real world example of a VPC with a private and public subnet set. So the entire VPC is 10.11.0.0/16. Since it's /16, the entire 2 last octets are available as IP addresses. So 10.11 is the network prefix. We can't change this. This has to be the same. 0.0.0 are the last 2 octets. And since we're using /16, both of those last 2 octets can be used for the private IP addresses. And our first public subnet can then be 10.11.1.0/24. So /24 means our last octet is available as an IP address. And we can make it anything between 0 and 255. So for our first public subnet, we can have any address that's 10.11.1.0 and 10.11.1.255. So this gives us 256 total IP addresses we can work with. And this is the same for our second public subnet. For our third octet, we just do 0.2 for our second public subnet to distinguish it from our first public subnet. And the same way, we can have any IP address that's within 10.11.2.0 and 10.11.2.255. And our private subnet 1 can be 0.3 for the third octet. And again, this is the same for the private subnet 2 as well. All we do is we increment the third octet to help us distinguish our different subnets. And we do this because it's /24. So this gives us the last octet to have for the private IP address range. So this is essentially how it works. Don't worry too much if you don't completely understand it. I've purposely kept this explanation concise to just give you just enough so you can successfully work with AWS. Because this is not a networking course. Having a complete knowledge of subnetting and private IP addresses is overkill and not necessary. So it's okay if you don't totally understand it. It will make sense once we actually set it up in AWS. And again, you don't have to completely master subnetting because this is not a networking course, and networking is not what this tutorial is focused on. And you don't need to master networking to work with AWS. So this is enough. So let's continue on to the next section.